Yes. Hey everyone, thanks for joining. Today I will be talking about why GraphQL is perfect for microservices. In a data that's been quite front-end packed, let's talk about something that's a bit more back-end, although microservices can be very relevant even though you're a front-end developer. So who's this for? I actually, something I wanted to say before is I'm not an advocate for microservices. They can be a very perfect use case for you, your team, or your company. But often it also looks like this. People try and make microservices out of their monolith. And in the end, they end up with something that might be even worse or not even have any coherent structure altogether. So whenever someone tells you you need to start using microservices, be critical. Maybe you need them, maybe you don't. But unless you're working for an enterprise, I wouldn't actually bother about going for microservices, but instead focus on making your existing monolith or whatever your APIs might look like better. A little bit about me was already introduced, but my name is Roy. I work with a company called StepZen. I'm responsible for developer experience and developer relations. Besides that, I'm writing books and speaking at conferences, so you might have already seen me around somewhere online, or maybe even in the past. I saw some people that I met a couple of years ago at one of the last actual conferences, so happy to see some people again. So what do you already know about GraphQL? Probably it's quite some bit. Maybe you're already working with GraphQL in your front-end project, or maybe you've seen it around in some side project. The one thing I do like about GraphQL, it's perfect for microservices. And why it's perfect? It's because it's really dynamic. So you might, sometimes people like to compare GraphQL with REST APIs. REST APIs have a tendency of having lots of different endpoints and a fixed data structure. So whatever REST API endpoint you will call, it will return the exact same data format every time you call it. Although looking at the different parameters, of course, but the fields are generally the same. And for GraphQL, that's definitely not the case. And if you're not that familiar with GraphQL, I would advise you to look into it, because I see a lot of front-end teams moving towards GraphQL, and hopefully more back-end teams later on as well. And it is perfect for microservices because it's dynamic. And it's really easy to extend things, to bring different types of data together, which I will show you in this talk. And it's all because it's all about graphs. So you can imagine if you have GraphQL, graphs already in the world, the idea is every data structure is a graph and can be combined with any other data structure. Of course, within the limitations of the underlying data source or the framework you're using to build a GraphQL API. And why it fits well with microservices, it's because they're both domain-based. So microservices are domain-based. If you would have one team working on, suppose you have an e-commerce application, one team is working on checkout, another team is working maybe on the product catalog, while another team is working on account management of users. All these services will have their own domain, and the same can be said for GraphQL. So suppose you have a front-end client, and if you have a microservice architecture, the interaction it will have for the backends will look something like this. So suppose you don't have an API gateway, or you don't have an API that will normalize and bring all the services together. It will look like this. You will have to interact with multiple services for every part of the architecture you want to fill with data. And all these services typically have their own domain. If we would give them names, you maybe have an authentication service, you might have a user service, and you might have a post service. In order to do something from your client, you would typically need to get an authorization token from your authentication service. You will get user information from your user service, which you need to supply with the token. And then the same can be done for post. But the interesting part here is if you want to combine data from users with posts, you will need to create some sort of layer that will bring these data together. So it can either be on your front end, which you'll see happening a lot, or it can also be in your back end in the form of a data layer or an API gateway. And if we look at microservices as being domain-based, you can also say that every microservice should have its own graph, or GraphQL schema as soon as you start adding GraphQL to the mix. So if we would have this overview of our architecture, you can see we have our authentication server, users, and post service. There are requests with the client application. And all these things need to be turned into graphs. So you can say every microservice will have their own graph, or every domain will have their own graph, or even every team that works on these domains will have their own graph that they're responsible for. And GraphQL can bring these things together in one schema, which is also the nice part, because I already said GraphQL is easy to extend, and it's really dynamic. So you can bring a lot of different types of data or structures of data together. And whenever you divide your services into graphs. So you have these microservices, they all have their own graph. Within something like a data layer, you can actually combine these schemas. So all the schemas from these services will be combined in this data layer or API gateway. And if you already have REST API microservices, you might be familiar with this pattern. Usually it's been called an API gateway or an API mesh. And this is truly the layer where all these services come together. Because typically, you don't want clients to interact with your microservice directly. You want them to interact with it through a different service. And merging GraphQL schemas can be done in multiple ways. As I said, GraphQL is easy to extend. So there has been a lot of different patterns in order to bring all these microservices and their graphs specifically together. Because the graphs don't have to be microservices, they can also be a third-party service, or maybe even different legacy services that you try to bring together. So the idea is basically that with GraphQL, you can merge different services together, and it doesn't really matter what type of service they are. So in the case of microservice, it's perfect because they will all be developed within your company. So generally speaking, it's easier. And one popular pattern is schema stitching. So schema stitching was actually the first pattern that was introduced in order to bring data together with GraphQL. And the idea here is that you will stitch multiple schemas together. So suppose you have one schema with your user information, another one with your post. You will bring these one together. And usually this will happen by creating another GraphQL API. And in order to make another GraphQL API, you would have to write a lot of code, which typically is in resolver code, to bring all these different schemas together. And you would also need to design some sort of master schema or like a main schema that is the, well, truly the one schema that all your services are supported with. So schema stitching was actually being deprecated by some companies and later on being revamped. So it's still a very good way if you want a programmatic way in order to bring your schemas together. There's also something called federation, which is, has less to do with building GraphQL APIs, but more with building schemas. So with federation, you will only use a GraphQL schema in order to bring schemas together. And this is especially popular within enterprises because it really depends on how your teams are structured. If you have different microservices with their own business domain, it's typically easier to use federation because no one is responsible for the end product. But if you have a team that's responsible for the end product, so let's say you have different teams, but there's one team that truly is the master of whatever will happen with all your different services, then schema stitching might be better. So federation is especially popular if you have the luxury of having different teams working on different parts of your architecture. And for this, I've brought an example, not using federation itself, but using StepSen. And the idea here is that you will have all these different services. They will all be turned into a graph. And then with GraphQL, they will be brought together. And if you want to try this out, I can show you some code if the time allows. So I'm first going to walk you through what these steps would look like. So the starting point will be to create a schema for every microservice. So you can either do this yourself, you can have it done with a tool like StepSen, or you can have it done by the team that owns this microservice. And if you would be using StepSen, it is really easy to connect any backend or data source. You can, in example, connect SQL databases, NoSQL databases, but also REST APIs or other GraphQL APIs. So suppose you turn your microservices that are using REST into GraphQL, you can just import them as REST APIs because your microservices typically will expose an API that can be used by either the client or by your integration layer. And for this, you can either use some curl commands. So you can actually use StepSen import curl and then append your REST API endpoint, and it will automatically generate a schema for you. Or you can actually use GraphQL schema design language in order to create the schema yourself. So it really depends on whatever you like. The import curl is really nice because it makes you move fast, while working directly with schema design language will make it easier for you to customize things. And in here, it doesn't really matter if you would use StepSen or any other GraphQL API framework. The idea is every service should have their own graph. And whenever you have created these graphs, you can bring them together either with schema stitching or federation. And merging schemas using StepSen can be done with just GraphQL schema design language, which means that you can create this whole data layer without having to write a GraphQL API with resolvers, with defining a schema, with caching. We're doing all the tricky parts. And I believe later today there will also be a talk about caching in GraphQL. And you can probably imagine if you have microservices, caching is more important because you can cache on the services itself, but probably you want to cache on a data layer instead. And then you can deploy them serverless without having to route any pipelines. But first, let's have a look at the example I brought with me today. Make this a tiny bit better. So I actually made some microservices in Node, which are nothing more than just a service that exposes some JSON. So I have created an authentication service here, I've created a post service here, and I've created a user service here. So these are the same examples you saw in the slides, and I will make sure you will have access to them later on. And for all these things, I've built a GraphQL schema. So the first thing you will do when you try to write a GraphQL schema for a microservice is get to know what types are in there. So if your service is for posts, you will probably have title, image URL, information about an author, and then you will need to write a GraphQL query for these. And a GraphQL query for these can be done with a custom directive called @rest. And if you would be using StepSend, it will turn this into a GraphQL API for you. And the nice thing here is that you can also input headers or use other type of configuration. And I've wrote multiple queries for this because the tricky part is if we would go back to the architecture, every time I want to make a request to my microservice, I need to give an authorization token. And for this, I need to do some extra work because you cannot just get the information about the post, you would also need to append a token. So the way to do this with something like StepSend would be linking multiple queries together. So you would have a query to get a token, and then you have a query to get posts. So the first step would be get your token, and then make sure that whatever the token will be, you will pass it on to the other query. And this can all be done with GraphQL schema design language. So you don't have to worry about what framework should you pick, what programming language should you use, and especially if you have distributed teams, you don't have to worry about one team building stuff in Java while another team uses JavaScript and another team uses Go, because GraphQL schema design language is universal for GraphQL, so you don't have to worry about these kind of things, which I can see for a lot of teams being a real addition, because if you're already talking about microservices and then you need to talk about the programming language or frameworks, you will get into, well, probably more discussions than actually building stuff. So whenever you've created a graph for all these different microservices, and as I said, you can do this with StepSend, you can do it with any other API framework, you will need to write some integration layer. And this can either be a GraphQL API that you write with JavaScript or TypeScript or any other programming language, or it can be just GraphQL schema design language. And in here you can see I'm using more queries that I try to tie together. And if you would go to a GraphQL playground for this, you can see there are multiple ways to get data. So if we linked all these queries together, you can get all the data at once, which is really nice for a microservice. If you would interact with every microservice individually, you would have to do all these queries one by one. So the first thing is you would need to get your token, and then whatever this token is, you would need to copy it, and then you would actually need to pass it to the microservice that returns your posts. Something like this. And then this should get my post data. And then you need to find a way to bring this data together. So if you're not working with a data layer, you would actually have to do all these separate calls from your front end and do the integration from there, which can be quite challenging and can also be leading to a lot of overhead because you need to make sure this data is integrated and being pulled in all together in a nice way. So I will also share the code with you later on. And the neat part is if you were building with StepSend, you can deploy them serverless. And you don't have to write any pipelines for this. So it will be fully performant and serverless, which will also help you because you can worry about integrating your microservices, about making sure they are available, but you don't have to worry about making the data layer itself available. So you can find the code on my GitHub, or actually the StepSend GitHub, in which you need to search for the microservices example. If you have any questions, I will be around for the rest of today. I believe we also have a app to ask questions, or you can just connect with me on Twitter and ask questions there. So thanks a lot, and I hope you learned some new stuff, and we'll learn plenty more in the coming talks. Thank you.